Right, so we're continuing from where we left off. We're looking at number 7 in this paper. We have 20 bags of sugar. The weights to the nearest kg are as follows. So we have some raw data, and we want to complete the frequency table for the data shown above. Now, we would use the frequency table when we have a lot of data, random information, and a large quantity. And if we have very close values, for example, we have 12, we have 11, you have, let's say, if we had a 17, it would make sense for us to create these groups or categories in which we will put them in so that we could check the number of bags or the number of observations, if we're talking generally, for any type of data set. So each one of these is a group, or what we would call a class, right? The class have what we call limits. So for example, the limits of this class will be 1 and 10. This one will be 11 and 20, 21 and 30, 31 and 40, 41 and 50. These are like the limits within which the values could fall within, and you will classify it as being part of that class. So for example, bags with the weight of 1 to 10 kgs include 3. We just go through each row, 8 and 5. So there are 3 bags with a weight between 1 to 10. So we'd say the number of bags in this particular class is 3. If we look at weights between 11 to 20, let's see what we have. We have a 12 here, we have a 11 here, we have a 18 here, and that's it. So we have another 3 bags that fall within this class. What about 21 to 30? Let's see. Oh, if we miss one here, there's 17 as well too. So that's 4 bags in that class. Right, let's just double check that we didn't miss any others. Nope. Right. So between 21 to 30, let's see. 21 to 30, this is gonna fit that. 30, this one, this one, this one. So I have 1, 2, 3, 4, 5. Right now in the tally column, when we have 5, we will draw it like this. Then we're doing 31 to 40. So 31. This is within 31 to 40. So is this. So is this. So is this. So is this. So we have 1, 2, 3, 4, 5, 6. And then 41 to 50, we have remaining 1, 2. And that's it. So this is how we complete our frequency table. Make sense? Everybody right to now? Let's talk about on this side. Now, I mentioned that each class have limits. So the limits of this class, so class limits, we have a lower limit and you have an upper limit. So for example, in the first class, the lower limit is 1, upper limit is 10. Second class, lower limit 11, upper limit 20. Third class, 21 and 30, and so on and so forth. We also have class boundaries. Now, the boundaries are like what we refer to as the outer layers. What are the extremities at which a value could fall in, and we will know to put it in a particular class, right? So, for example, what if I had a bag that weighed 0.8 kgs? How would I know what class to put that in? Or what about if I had a bag that weighed 21.7 kgs? Do I put that in the class 11 to 20, or do I put it in 21 to 30? So the way in which we would treat with scenarios like this is the upper class and lower class boundaries help us to define the outer layers of each class. The lower class boundary for any class is always 0.5 less than the limit. So for example, in our first class, the boundary will begin at 0.5, right? So if X is our observation, that's the weight of our bag, anything that is greater than 0.5 will fall into the first class. Anything that is greater than or equal to 0.5 would fall in this class of 1 to 10. And anything less than 10.5, we just add on a 0.5 to our outer limit, will also fall in this class. So if we had a bag of sugar that's 10.4 kilograms, sorry, then that will go in our first class. If it was 10.7, it will go in our other class, because the lower boundary, could abbreviate that as LCB, and upper class boundary for our second class, this one, will be 10.5, right? Greater than or equal to 10.5, but less than 20.5. So something like 10.5 will go in this, 10.7 will go in this class. But if we have 20.5 on the dot, remember it says it's less than 20.5. So 20.5 will have to go in this class. This class, the boundaries will be 20.5, greater than or equal to, or less than 30.5. So the upper class boundary for 21 to 30 is going to be 30.5. The class width is always the difference between your upper class boundary and a lower class boundary. So if we use the same class here, this class interval 21 to 30, our lower class boundary is going to be 20.5. And our upper class boundary is going to be 30.5. And if we subtract those two, the width is 10. The class midpoint is our average of the limits. So we will add our upper limit and our lower limit and divide that by 2. So if we use the same class interval, 30 plus 21 divided by 2, that's 51 divided by 2, that's going to give us 25.5. And that's how we would treat with a question like this. Yeah? All right, for this other question, or the other part of the question rather, we want to draw a histogram to represent the data that was in the frequency table. So I added the frequency table on the side here because we need to include another column to do it. Now, there are two ways in which we could draw a histogram. We would usually plot the frequency, right, which is the number of bags. We could plot that against our midpoint, which is the method that I would be using to draw our histogram today. Another way we could do it is we could actually use the boundaries of each of the classes as our increments on the x-axis, and we could plot the class itself against the frequency, right? Both methods are correct. We will use the method of using our midpoint. So with that in mind, what I need to do is I need to add an additional column here where we will work out the class midpoint. Remember, I told you guys the midpoint is like the average of each class, right? So the average weight of any bag of sugar falling in this first class, so we could write here class midpoint, or abbreviate it, right? We will add these values. 1 and 10 is going to give us, I'll just do an example up here. 1 plus 10 divided by 2, 11 over 2 is going to give us 5.5. Right? We saw that in the earlier part of the question. So I'm going to get 5.5 here. Right? 11 plus 20 is going to give me 31. 31 divided by 2 is going to give me 15.5. 21 plus 30 will give me 51. So my midpoint for here is going to be 25.5. 31 and 40 is going to give me 71. So that's going to give me 35.5. And 41 and 50 is going to give me 91. That's going to give me 45.5. Yeah? So these are my midpoints. So I am plotting my midpoints. Is going to go on my x-axis. And this here is what we call our frequency. this is how frequent this particular observation of a bag being between the weight of 1 to 10 occurs. This is going to go on my y-axis. Now they gave us a scale to use. So 2 centimeters, every one of these blocks is 1 centimeters on our graph. So on our x-axis, we are going to represent 10 kgs by 2 centimeters. Now, what we will do is every 2 centimeters. So from here to here is going to be 10. Here to here is going to be 20. Here to here is going to be 30, 40, 50, 60, 70, 80. Now, the thing about histograms is that the width of each column needs to be uniform. This is why I'm going to be writing our class midpoints in here. 5.5. This is going to be my 15.5 in the middle. Then next you're gonna go to 25.5, 35.5, 5.5. And that's where we'd stop, right? Because we're going all the way up to 50. So this is my x-axis. On my y-axis, we're using 1 centimeter to represent a bag of sugar. So in total, the highest frequency occurring is 6 bags, right? So we're looking at the largest occurring observation, 6. So we increase in here 1 unit at a time. So 1, 2, 3, 4, 5, 6. And let's block some other values going up to 10. Right. So for our first class interval, which is 5.5, our frequency is 3 bags. So choose another color. Choose pink. Blue. So our first bar is going to be here. So I have this option to do. All right, so we draw the other diagram, the other bar now. The other bar is going to be 4 is our frequency. And we're looking at this column here, 11 to 20. So the other one, now with the histogram, they actually stacked on top of each other. So there are no spaces between the bars. Right? Then the other one we're looking at is going to be 5. So we're going up to 5 now. And then the other one we're going up to is 6. So that column is going up here. And then the other column is going to be 2. When you're doing it, you'd use your ruler, so it'll be a little straighter than that, right? Always remember to write in your scale as well. So you write in your scale, x is equal to 2 centimeters to represent 1 unit, right? Or 10 kgs. Y, we're doing 1 centimeter to represent 1 bag. And label the axes, Y and X. Everybody all right to that?